Hello everyone. I hope you all are doing good. This is Lakshmi Narayana, Senior Physics Faculty. Okay, we are on time. Let's wait for a few more seconds to others join the session. Okay, so last section we discussed about electricity part 1, and this session we are going to discussing about electricity part 2. Okay, I hope you all enjoy the last session, and this session also we continue with the same fun and same enjoyment. Okay, so without any delay, can we start our session? Yes, yeah, okay, yeah. So before starting the section, you have to recap what we discussed in the last session. Okay, in electricity part 1, what we discussed. Okay, just recapitulate everything. Okay, yeah, chat box. If you have any doubt, you can comment in this chat box. Okay, yeah, hi sir, hi, so many highs. Okay, yeah, good to see. Okay, so can we start without any delay? Yeah, welcome back again. This is Lakshmi Narayana, Senior Physics Faculty. Okay, see, electricity. Okay, in previous section part 1 we discussed it, and today's section we are going to discussing about electricity part 2. Okay, yeah, see, in this section what are the topics we're going to cover? We're going to discussing with resistance of system of resistors. Okay, in today topic we're going to discussing about resistors. Okay, in last class also we discussed about resistor. In today's section we are discussing about system of resistors. Okay, system of resistor or combination of resistor. In the combination of resistor we have two types, series and parallel. Okay, what is mean by series, what is mean by parallel? So in already last session we discussed about what is series and what is parallel, right? Okay, what is mean by series? End to end connection. Like if you take a train, how the bogies are there? End to end connection is there, right? That is series. Okay, side by side is there, that is parallel. Okay, so end to end connection. Series means in shortcut end to end. Okay, end to end is series. And what about parallel? Take 2 points, x is 1 point, y is 1 point. In between these 2 points we taken number of rays. Okay, taken number. See, at x and y divided na, x and y, between x and y we have a 3 paths. This is parallel. Okay, 1 by 1, 1 by 1, 1 by 1. Okay, end to end series, 1 by 1 parallel. Okay, and next topic is that heating effect of electrical current. Heating effects of electrical current. And next, electrical power. Next one is what? Electric power. Okay, yeah. Can we start? Yes. See, resistors are in series. Resistors are in series means what? How it will be series? If you are taking a, for example, I am taking resistor here. One resistor. Another resistor. Okay, here it is end. Here it is end. Another resistor I am continuing. See, here it is end point na. This is the end point of a first resistor R1, and R2 connected to end point of first one. Similarly, at end point of R2, I am connected one more. So what is this? This is a series connection. What is this? This is series. So series means end to end connection is called as that series connection. Okay, end to end. End to end is called as that series connection. Okay, see, look it in the diagram. Look it in the diagram how R1, R2, R3 are connected. End point R1, this is the end point of R1, this is the end point of R2, this is the end point of R3. So resistors are connected one by one. Okay, end to end, end to end, end to end connected means resistor. How trail bogies are there, one after another, right? So that is resistors are series. Okay, if the resistor on series, how the flow will be? How the flow will be? This is a very important point. Okay, if the resistors are in series, how the flow will be? Look at the diagram, circuit diagram. See, what is this? This is battery. This is battery. Why it is battery? Number of cells. Okay, number of cells or combination of cells we called as that battery. From the positive terminal, the current is flowing. Where it is? It reaches ammeter, it passes ammeter, and it end here. Okay, it passes here at X. See how ammeter and how voltmeter is connected. Voltmeter is always connected in parallel. In last class also we discussed the same thing. How we connect the ammeter and voltmeter. Maybe there is a chance to asking about, okay, in examination, how voltmeter we connected in a circuit, how ammeter is connected in a circuit. Okay, remember, voltmeter is always connected parallel, ammeter is always connecting in series. Okay, ammeter is always connecting in series. Next, see at X point what happened? The flow is there. At X flow is there. See R1. What is R1? Resistor of the first. R2. Resistor of the second one. R3. Resistor of the third one. So resistance means what? Slow down the movement of an electron. Okay. What it do? What it do? It opposes the flow. That's it. Okay. Resistor means what? It opposes the movement of an electrons. Okay. If the electrons are coming this direction, opposing. Okay. Passes R1. Again R2 is there. Okay. R1 passes. Again R2 is there. R2 passes. Again R3 is there. So how the flow will be? The flow is same at every point. Okay. How the flow? Flow is same. Flow is same. In which circuit flow is same? Which circuit the flow is same? In series the flow is same. What it is changes? Potentially changes. Okay. In a series circuit, flow is remains the same. Potential is varying. Okay, for example, in front of me, 3 speed breakers are there. Okay, apart from each speed breaker, 2 meters or 5 meter distance is there. Okay, first I cross the speed breaker. When I crosses the speed breaker of first one, coming to the second speed breaker, I have same potential or potentially changes. Potentially changes. Potential changes. Na? And coming to third speed breaker, there also potentially changes. And what about my flow? Flow is what? Flow is reduces. But how the flow will be? Same only na. How the flow will be? Flow is remains the same. What it changes? Potentially changes. Okay. Remember, when resistors are connected in series, what it is same? Current is same. Current is nothing but flow is same. And what about a potential? Potential is varying from one resistor to another resistor. Okay, first one I cross with some potential, and coming to the second one, can I face same? No, right? Okay, for example, if I am playing a match, I have 3 matches: quarter final, semi final, final matches. 3 matches are there. If I play quarter final, if I win, okay, and semi final also with the same potential, it's not possible, right? The potential is decreases. Now already completed one game, the potential is decreases, right? So here also, when resistors are in series, what it is varying? What it is varying? Potential is varying. Okay, the same current through each resistor. When the current is same, when the resistors are connected in series. Clear? Next, next. See, resistors are in series. How the all the resistors are connected? For each resistor potential is there. V1, V2, V3. How the potential are connected? Potentiometer connected. How voltmeter is connected? Parallelly. Okay. How voltmeter connected? Parallelly we connected. See, here amount of current is enter here. Here amount of current is enter, and if passing like this, current is flow is passing like this. What happened here? Potential is variated. How much potential takes place in R1? That potential we will calculate by using voltmeter V1, and after crossing the P, it is entered Q. R2, it is entering R2. At R2 also have another potential. That potential calculate at V2. Okay, and similarly at R3 have another potential. See, here current is I. If I is the amount of current is entering R1, R2 also same amount of current, no changes. R3 also same amount of current, and leaving the R3 also same amount of current. Finally coming to ammeter, same amount of current, and reaches here also same amount of current. So the current is remains same when the resistors are connected in series. Okay, what changes? Potentials are changes. Okay, so I would like to calculate total potential or net potential. Okay, total potential or net potential in the circuit. How much voltage is present? How much voltage is present? See, here voltage V1, net potential na V net or V total is equal to total potential. How we can calculate? Adding up those potential, right? So V1 is the first potential, V2 is the second potential, V3 is the third potential, because potential only is variating. So if you want to calculate total potential, means total potential V is equal to V1 plus V2 plus V3. Okay, total means adding. Okay, V1. So at V1, what is the V1? At V1, V1 means from the Ohm's law we take V is equal to IR from Ohm's law. From Ohm's law, what is the relation between these three? V is equal to IR. Okay, at R1, what is the potential? V1. So V1 means current is I only, resistor R1. At V2, current is same only, resistor R2. At V3, current is same only, resistor is R3. And total net current. Okay, throughout the circuit, what is the current? I only. What is the current coming out from the battery and reaches the battery also same amount of current. Okay, I is the total current, and resistance, total resistance is series na RS. Total resistance RS. See, calculate I. Then what is the remaining? Total resistance RS is equal to R1 plus R2 plus R3. Okay, when you will get all the resistors are in addition, when the resistor connected end to end, it means series connection. When the resistors are connected in series, the equivalent resistance, the total resistance of the circuit RS is equal to R1 plus R2 plus R3. Or okay, or simply if you want to remember, means if you want to get the total resistance of the circuit resistance, check whether it is series or parallel. If it is series, add all. How many resistors are there? 3. R1, R2, R3. So add R1 plus R2 plus R3. That is the resistance in series. Equivalent resistance. RS is equal to R1 plus R2 plus R3. Okay. Next, resistors are in parallel. Next one is what? Resistors are in parallel. Parallel means what? Let us take 2 points. X is a one point and Y is another point. Okay, between 2 points we have number of paths. Different paths we take it. See, this is a one path. This is second path. This is the third path. Okay, look at here. From the battery, current I is coming. how much current is coming from the battery? I is the amount of current coming from the battery. Up to point X only, the current is I only. But whenever, see here, how many paths are there? 3 paths are there now. So the current is split into 3 paths. The current splits into 3 paths. How many paths you given to flow of current, that many paths will be there. For example, simply see here, I am taking a one tube here. One tube I am taken here. And to this tube, I connected another two tubes. Another two tubes. Okay. See here, water flow is there. Water flow. Which flow? Water flow. Water flow. See which direction the water flow is there? This direction also flow will be there. This direction also flow is here. Okay. If it is equal area, if area is equal, the flow will be same. See here water is entering and at this point X it dividing into 2. The water flow. Okay. How we connected water? Okay. Similarly, total calculate I or flow. Total flow is equal to flow of the first one plus flow of the second one. Then you will get total flow. Then you will get total flow. So here also what happened? 3 different paths are there. Then what it will be divided? Current will be divided. Okay. Current is divided. Here it is I1. Here it is I2. Here it is I3. So current splits into 3 paths. If it is 4 paths are there, then it splits into 4 paths. If it is 5, divides into 5 paths. Okay. So what is the current is coming through the R1? I1 is the current. And what is the current is coming to R2? I2 is current. What about R3? I3 current is coming. Okay. Whenever current is divided, okay, the potential are same. What is the potential? Potentials are same. See, at X, okay, see I1 R1. Here potential I2 R2. Here potential I3 R3. If resistors are in parallel, okay, remember blindly, resistors are in series, flow is same, current is same. Resistors are in parallel, potential is same. Okay, when potential is same, resistors are parallel. When current is same, resistors are in series. Okay, so now potential is same now. Potential is same through each wire. 3 wires. Each wire 1, 2, 3. In each wire the potential is same only. And what it is divided? Current is divided. Then what is the total current? Total I total in the circuit is equal to I1 plus I2 plus I3. Okay, if you want to find out the total current, I total is equal to I1 plus I2 plus I3. Okay, total current, because current only na dividing. Initially what we taken, potential is divided, then total potential in the circuit V is equal to V1 plus V2 plus V3. But here potential is same, current divided. Then total current I is equal to I1 plus I2 plus I3. Okay. Then from Ohm's law, V is equal to IR. V is equal to IR. Then I is equal to V by R only. Then substitute total current, total potential by total resistance. Okay. If you want to get total current means total potential by total resistance. I1 potential is same now. Potential is same now. Potential is same, right? Okay. So V by R1, I2 is equal to V by R2, I3 is equal to V by R3. So potential same. Then cancel it. 1 by Rp is equal to, Rp means R parallel, resistors are parallel. 1 by R1 plus 1 by R2 plus 1 by R3. Okay. This is the formula for resistors are in parallel. Resistor series means addition 1 plus 2 plus 3. Resistors parallel means 1 by R1 plus 1 by R2 plus 1 by R3. Clear? Yeah. Next, see current X divided 3 parts, I1, I2, I3. Okay, I1, I2, I3 divided. And what is the total amount of current coming? I is the amount of current. I is the total amount of current through the circuit. I is equal to I1 plus I2 plus I3. Next, yeah. Now see, solution. Look at the question first. Okay. What you are observing in the question? The many students are facing an issue in the numericals, especially in the chapter of electricity, because they're confusing about potential and potential differences and all. Okay, and how the resistors will be. Resistors are series means which formula we have to take, which is constant. If resistors are parallel means which is constant. Okay, you are confusing. Yeah, see, I will explain how to solve the numericals in a simple way. See, first of all, read the question. How can three resistors of resistance? How many resistors are there? Three resistors. They only say three resistors are there. What are they? Did they mention any names? No. So we take it is that 2 ohms is R1, 3 ohms is the R2, 6 ohms is that R3. So we take in three resistors as per the question are connected. Okay, they are connected. R1, R2, R3 are connected. And if you connected, given a total resistance. So if you connected, it give 4 ohms, and if you connected 1 ohms. Okay. As per the question, they given 3 resistors. Okay. If you connected these 3 resistors, one time you will get 4 ohms. And if you connected these 3 resistors, again you will get 1 ohms. How it is possible? Let us check. See, given for every numerical, the important one is the given information. Okay, given information. For the given information also marks will be there. So given, what is given? R1. Let us consider R1 is equal to 2 ohms, R2 is equal to 3 ohms, R3 is equal to 6 ohms. So 3 resistors are given. We are considered as R1, R2, R3. Now, if you connected these 3, first you connected means how much you get? 4 ohms. How it is possible? How can we connect? I'm taking here, I'm taking R1 like this. Okay, R1, I'm taking like this, and here R2 and R3, or I am connecting like this. Okay, like this I am connecting. See, which are in series, which are in parallel? From the circuit diagram, tell me which are in series, which are in parallel. End to end. For example, I is the amount of current is passing. R2, R3. How this R2, R3? How the R2, R3? Parallel, right? Right? So, first I am taking a parallel. What is the formula for parallel? 1 RP is equal to which are parallel? R2 resistance and R3 resistance. 1 by R2 plus 1 by R3. So, 1 by R2 value 3. 1 by 3 plus R3 value 1 by 6. So LCM is what? 6. 2 plus 1, 3 by 6. Then 1 by 2. Then the total resistance of R2, R3 combinedly how much? 1 by RP is equal to, then resistance are parallel. 1 by RP is equal to 1 by 2. Then RP is equal to 2. Okay. The total resistance of R2, R3 how much? The total resistance of R2, R3 how much? 1 by R2 plus 1 by R3. How much we will get? 1 by RP will get. The value of RP is the 2 ohms. RP is the 2 ohms. These 2 ohms, how we connected to R1? If you want to get 4 ohms, tell me anybody from comment section. The total resistance of R2, R3, I got 2 ohms. When I connected in parallel, R2, R3 especially connected in parallel, by the connection of R2, R3 parallel, I get the value is 2 ohms. These 2 ohms, how you connect it to the R1 to get the value of 4 ohms? How we connect it? Anybody from comment section? Anybody? See, they got an answer. Very fast, na? See, how they connected? If you want to get 4, already 2 ohms are there. If you want to get 4 ohms means how we connect series or parallel? From the comment section, they give an answer also for first one and second. How they connected? Series they connected. See, the total resistance of R2, R3, 2 ohm. Na? These 2 ohm, if you connected, okay, this is R1. This is R1. And to this R1, they connected RP value series. RP value. RP value how much? 2 ohms. R1 value how much? 2 ohms. Then the total value R1 plus RP is equal to 4 ohms only. You got na? You got it na? 4 ohms. So first one completed. And second one, the question is not completed yet. Okay. 1 ohms. How you get 1 ohm? Anybody from comment section, how you get 1 ohm? Huh? You got 4 ohms. How you get 1 ohm? See, here R1 is there. Here R1 is there. What is the value of RP? 2 ohms. These 2 ohms, if I connect it to the R1, the 2 ohms, if I connect it to the R1 parallelly, now calculate R1, RP. How these two will be? Both are parallel. Then what is the formula? 1 by R parallel 2 is equal to 1 by R1 plus 1 by R parallel 1. 1 by R1 value 1 by 2. 1 by R parallel value 1 by 2. Then 2 by 2. Then 1. Got it now, 1 ohms? Very simple. Very simple. Clear? Yes. Okay. See how it is. Okay. Next. In a circuit, 3 resistors R1 10, R2 10, 20, R3 30 are connected parallel to a battery of 12 volts. Okay. So as per the question, you have to draw the diagram for better understanding. Okay. So see how I am drawing. Similarly, you try for other questions. Okay. Given what given? 3 resistors are there. R1 10 ohms. Okay. R1 10 ohms. Next R2 20 ohms. R2 20 ohms. Next R3 how much? 30 ohms. R3 30 ohms. So I am taking R1, R2, R3. How they connected? Connected parallelly. Parallelly means take 2 points. X is 1 point, Y is 1 point. X connecting R1, R2 connecting X, R3 connecting X. Similarly, R1 connecting Y, R2 connecting Y, R3 connecting Y. Now all are parallel. That's it. Okay. Now current is divided. Okay. So to which one they connected? Connecting to the battery of battery. How much volt? 12 volts battery. Okay. See, through the 12 volts, how much current is coming? I is the amount of current is coming. And here at X what happened? Current divided na, because 3 paths are there. I1, I2, I3. 3 paths are there. Okay. And after passing R1 also, I1, I2, I3. So again here at point Y all are mixed. I is the amount of current is coming again to the battery. Okay, this is the diagram. Next, what do you want to find out? Current flowing through each individual resistor. Okay, current finding through each individual resistance. See, we know find outing a resistor, what are the variables are required? Voltage is required, current is required, resistor is required. Resistors are given, potential is given. So many are confusing at this point only. Resistors are given, you like to find out current in each resistor, and potential is given or not. See, potential is given. Yes, potential is given. The potential is same at every wire. Why? Because all are parallel. Okay, all are parallel. From the Ohm's law, V is equal to IR na. V is equal to IR na. Remember the formula of Ohm's law, because many numericals by solving based on the Ohm's law only. V is equal to IR. From that, V is equal to IR. Calculate. I am calculating that. I1 is equal to V1 by R1. I2 is equal to V2 by R2. I3 is equal to V3 by R3. Simple. I1 is equal to V1 by R1. I2 is equal to V2 by R2. I3 is equal to V3 by R3. Here the common is what? Potential is common. Potential V only. R1 how much? 10. Potential V only. R2 how much? 20. Here V3 potential is V only. R3 30. Now calculate. 12 by 10. 12 by 20. Potential is same now because circuit is parallel. 12 by 30. See, 12 by 10. 12 by 10. 1.2. 0.6. 1.2 half. 1.2 by 20 na. 0.6. And here again 3, 12. Okay, 3, 0.4. Okay, 1 by 3 na. 1 by 3 into 1 by 10. 1 by 3 into 1 by 10. So 12 by 3, 4 times. 4 by 10, 0.4. So the total current means I is equal to I1. See, I1, I2, I3. Add all this. I1 plus I2 plus I3. How much I1? 1.2, 0.6, 0.4. 0.6 plus 0.4. 1. 1 plus 1.2, 2.2. So then I is equal to 2.2 amperes. Done na? The current flowing through each individual resistance we find out. I1 1.2. Okay. Through the resistor of R1 how much? 1.2. Through resistor of R2 0.6. Through resistor of R3 0.4. We find out each individual current. Okay. Next, total current also we done. Total current I is equal to I1 plus I2 plus I3. In the circuit, how much current is present? It means summation of all these three. I1 plus I2 plus I3. I1 1.2, I2 0.6, I3 0.4. Then adding all total current in the circuit by the 12 volts battery. How much? 2.2 amperes. Next, the question not yet completed. Total effective resistance. Effective resistance means R effective or R total. R effective or total. Total potential you know. Total current you know. Then current you know. Potential you know. Then easy to calculate the resistance of the circuit, right? Effective resistance, right? Anybody from the comment section? What is the formula we use? What formula we use to calculate the effective resistance of the circuit when they given about potential and total current? What formula? V is equal to IR, Ohm's law. See, V is equal to IR, voltage 12, current 2.2, resistor don't know, that only we going to find out R effective. then R effective is equal to 12 by 2.2. How many times? 2. 12. 5 na? 6, approximately 6 will be there, but 2.2 is there, right? Then 5.45 amperes. Okay, 5.45. 5 to is 12. 5 to is 10. 4.5. Okay, so 5.45 is the effective resistance of the circuit. Clear? Okay, this is the way to solve. Okay, yeah. Next one. In figure, R1 is given, R2 is given, R3, R4, total 5 resistance are given. Total 5 resistance. In examination also, maybe they ask you like this only to trouble you. Okay, but don't worry. Okay, here I will help you to how to solve this kind of problems. See, total resistance, how many resistors given doesn't matter. Okay, if you know the concept, resistor connected in series, then it is series only. Resistor connected one by one, parallel only. Okay, parallel is the resistors are parallel. What it is divided? Current is divided. Resistors are series, voltage divide. Simple. B is equal to IR. How the voltage, how the resistors, how the current will be. Resistor series, potential divide. Resistors parallel, current divide. So it completely based on the resistors. Okay, so focus on the resistor. See where it is connected, 12 volts battery. How they connected? Connected to the arrangement. Calculate total resistance. Again effective resistance only, R effective. Okay, and next total current. Two things we are going to find out here. Listen, two things. What are they? Total resistance. See, two different resistors are given, right? In two cases. Here R1, R2. From the battery, I is the amount of current is coming. Look at this point, let us take it is X and this is Y. What happened? At this point, the current is divided now. Here it is going I1. R1, R2 are parallel. That means which one divide? Which one divides? Current divide. I1, I2. So current is divided. Okay. Through the R1, how much current is passing? I1. Through R2, how much current is passing? I2. So I1 is going to R1, I2 is going to R2. Okay. See, R1, R2. Then if you calculate the total resistance here, 1 by Rp is equal to, for first one, first diagram, 1 by Rp1 is equal to 1 by R1 plus 1 by R2 na. So 1 by R1 value how much? 10. 1 by 10 plus R2 value how much? 1 by 40. 1 by 40. Let us take 1 by 10 common. 1 by 1 plus 1 by 4. Okay. 1 by 1 plus 1 by 4. So 1 by 1 plus 1 by 4, how much will be? 1 by 1 plus 1 by 10 plus 1 by 1 plus 1 by 4. LCM is how much? LCM is how much? 4 is the LCM. Right. 4 plus 1. 5, 4 plus 1. Okay. So 5 by 40. How many times? 1 by 8. So this is the first circuit of diagram. First circuit diagram, RP1. Then RP1 value 8. Okay. So combining of these two resistors, what is the total resistance of R equivalent R effective of R1 and R2? How much? 8 ohms. Okay, we completed R1, R2. Remaining R3, R4, R5. How it will be? Again, the current is combined here. I is the amount of current coming. Here also I is the amount of current coming. But here through R3 again divided I3, again divided I4, again divided I5. So current is divided. Calculate the resistance of R3, R4, R5. Anybody? Anybody? R3, R4, R5, calculate. R3. In parallel only na formula. 1 by RP2, second circuit diagram RP2 value. 1 by R3 plus 1 by R4 plus 1 by R5. That's it. Only 3. Okay. Below 3 only na. 1 by R3 value 30. R4 value 20. R5 value 60. Take 10 common. 1 by 10. 1 by 3 plus 1 by 2 plus 1 by 6. LCM. LCM. 3 2 6 LCM. 3 2 6 LCM. बताओ. Tell me. 2 times. 12. Right? 12. 1 by 10. 4 plus 6 plus 2. Okay. Then 6 plus 4. 12. 12 by 12. 12 by 12 into 1 by 10. 12 by 12 cancel. Then 1 by 10. So this is the RP2 value. Then RP2 is equal to 10 only. Okay. The combination of these three, R3, R4, R5. So combination of these three, R effective is equal to how much? R effective is the 10 ohms. Okay. By the R1, R2 we get 8 ohms. By the R3, R4, R5 we get 10 ohms. So what is the first one? Total resistance. Total resistance. So how much total resistance will be? R total is equal to RP1 plus RP2 only. RP1 how much? 8 ohms. 8 ohms. RP2 10 ohms. Then totally 18 ohms. Simple. Simple. Total resistance in the circuit is 18 ohms only. The question is completed. Not yet. See, resistance we find. Next, total current. Tell me formula. Which formula from comment section? Which formula? Which formula from comment section? What is the formula? Resistance is given. That we find out total resistance in circuit. Current we are going to find out. Potential is given. So among these three, what relation is there? V is equal to I R. V is equal to IR only. V is equal to IR. From Ohm's law, V is equal to IR. What is the voltage? What is the voltage? Voltage is given. Yes, given 12 volts. 12 volts. Resistance. How much we calculated? 18. 12 by 18 is equal to total current. I total. I total is equal to 12 by 18. Calculate 12 by 18. 2 table 6, 9. Again 3 table 2, 3. So 2 by 3 is the total current. Okay, again if you calculate it 2 by 3, 0.6 something will come now, 0.6 ampere. That is the I total. Okay, the total current in the circuit is at 0.6. 2 by 3. 26 times 0. Okay, 0.6 ampere is the total current is present in the circuit. Clear? Next. What is the next topic? Heating effect of electric current. Heating effect of electric current. See, if you take any electronic devices, if it works continuously, what happens? Even like fan also, or bulb also, or any electronic devices like mobile or laptop, okay, TV, any electronic devices, it works continuously. What happens? It produces some amount of heat. Yes or no? We are already experiencing in a daily life. If you are using continuously mobile, after some time it gets heat only. So why it gets heat? Why it gets heat? See, a part of the source energy in maintaining the current may be current useful work. Okay, daily life without electricity is not possible. Okay, we will stay without friends also, but we cannot say without electricity in a daily life. Yes or no? Hmm? Yes, yes, sir. In comment section, they giving yes, sir. Without friends also, we will be there. Without mobile phone also, we are not there. Yeah, because we are happy to. Okay. See, yeah, useful work. So, which work we are doing? Rotating a fan, rotating an electrical fan. How the electrical fan works? Because of electricity only, na. Otherwise, some person will be there rotating with the finger. No, right? See, so rest of the source in the form of heat. Okay. For example, I am taking a one battery here and I connect it to the bulb. So some amount of current is passing through the bulb. Then the bulb glow. Then the bulb glow. After continuously working, what happened? From the bulb only, I get some amount of heat. I get some amount of heat. Why I get some amount of heat? Through the bulb. I am given electricity. I am not given any heat. But heat comes from the bulb. Why? Because what the bulb doing a work. What kind of work? It produces a light energy, right? Because it continuously working that light energy, it gives some amount of heat. How the heat comes? The resistance. Because of resistance, if it is having more resistance, more amount of heat it is produces. Okay, see, rises the temperature of the gadget. Why the heat comes? Temperature of the gadget rises. If I am using continuously mobile phone, allow temperature rises na. Okay. For example, an electrical fan in a daily life, we experience that only, which are the electronic devices we are using in daily life. Those all are producing a heat. Okay. Yeah. And produces a warmth continuously for long time. If it is in continuously long time, what happens? Produces more amount of heat. This is called as that eating effect of electrical current. Simply eating effect of electrical current means if any electronic devices continuously work. To continuously work means what required to work? First of all, electricity is required. This electricity is not giving to work. Okay, it produces some amount of heat by the device also. The process we called as that eating effect of electrical current. Okay, eating, not eating. Okay, don't keep H silent. If you keep H silent, eating. Okay, eating effect of electrical current. Okay, if you keep the silent of H, eating effect of electrical current. What current eat? Okay, so eating effect of electrical current means what? If you use any device continuously, it produces some amount of heat. This process is called as that eating effect of electrical current. Simply, if you, in the examination, if you not remember means, look at the fan. Continuously work. To work continuously, what required? Energy is required. Okay, the fan is continuously working means from the fan also you'll get some amount of heat. This total process we call as that eating effect of electric current. Understand? Yeah. Next, see, power. Okay, the power input to the circuit by the source. How much power? How can we calculate power? Okay, there is a bench here. I am pushing the bench. I am doing work on the bench. Okay, how can I calculate the power? Power P is equal to work done by time. Okay, work done by time. For example, there is a one box here. There is a one box here. I move the box from A to B. A to B. I moved a box. For moving the box, I am taken 10 seconds of time. For moving a box A to B, I am taking time of 10 seconds. So I complete my work in 10 seconds. And another person is came. Okay, another person is came. For example, Bahubali came. Bahubali came. Bahubali came, applying a force here, applying a force here. He completed the work in 1 second. He completed the work in 1 second. Who is more power? How can we calculate the power? How can we calculate the power? I also did the same work. Bahubali also did the same work. Who is more power? How can we calculate the power here? How can we calculate? Who takes a less time? I am taking 10 seconds from A to B. Bahubali takes just 1 second. Fraction of seconds. Okay. Within 1 second, it moved from A to B. Okay. Who is having more power? Bahubali is having more power than me. Okay. See, if you take how the power and time inverse. How the power and time inverse. If time increases means power decreases. Time increases means power decreases. Time decreases means power increases. Simple. I'm taking less time. I have more power. I'm taking more time. I have less power. Okay. So power is equal to work done by time. So what is the relation between work done and potential? What is the relation? In potential we discuss na. V is equal to W by Q. Then W is equal to VQ. Substitute here VQ by T. So Q by T again I is equal to Q by T na. So in place of Q by T substitute I. So power P is equal to VI in terms of potential and current. P is equal to VI is the formula in terms of potential and current. So P is equal to VI. Next, the energy dissipated in the form of heat only, that we know. Okay, if any device works continuously, electronic devices, it produces some amount of heat by the steady current. Okay, remember the term steady current. Steady current means the flow is same. If I turn on the tap little bit, water is coming, each drop, how that flow will be same, right? So if you connect it to the battery also, from the battery the current will be steady, means remains same flow will be there, same flow will be there. Okay, and the amount of heat produces in time of t is that, for example, the fan is continuously working. Okay, continuously working, it produces heat na. How can you calculate that amount of heat? How can we calculate that amount of heat? See, H is equal to VIT. Okay, heat. H is equal to VIT. It's a product of potential, current, and time. Or else write heat producing per time. That is equal to VI. That is equal to power. Okay, heat produces per time. If you use continuously, okay, I am using a one company fan, you are using another company fan. Okay, another company fan produces more amount of heat in a same time. Who is having more power? Time taken less, power is more. Okay, H is equal to VIT. H is equal to VIT. The amount of heat produces in the given component means how can we calculate? Potential and current and time. Okay, product of potential, current, and time. Next, yeah, it's your favorite time. It's your favorite time, na? Okay, have a 2 minutes break. After 2 minutes, again, we'll start the section with the same energy, with the same joy, and with the same. Okay, yeah, see you after 2 minutes. Have a break. You enjoy your break session, right? Yeah. So let's start without any delay. Waiting. Yeah. Okay. Yeah. Let's start our session very quickly. Joule's law of heating. Joule's law of heating. So, what is the Joule's law of heating? If any device, okay, any electronic devices works continuously by the electrical current, it produces a heat. That is called Joule's law. Okay, how much work it do? Okay, how much work per time? That only in a power. Okay, work done per time. See, an electrical fan is there, it's doing more work. The fan is working, or any electronic device is doing more work per time. That is power na. More work per time. Work done per time. Power. See, work. So whenever the work is done, it produces an amount of heat H by time. So energy per time. In place of work done, I am writing energy per time. For doing any work, what required? Energy is required. How much work is done, that much amount of heat produces, right? If I am continuously thinking, brain, amount heat generated. No? No, just casually. Okay. So if continuously working means heat generated. If continuously riding a bike, work is going on. Because of that work only heat generated. So work in place of heat time replaces. Okay. H by time. That is equal to power. Power is what? Power is equal to VI. Na? Power is equal to VI. Na? So work done by time is equal to VI. Or H by time is equal to VI. So H is what? Amount of heat. Then H is equal to VIT. Okay. This is called Joule's law. Okay. So Joule's law. So see, I am writing that VI. Okay. VI. VI. So what is I value from the Ohm's law? What is I value? V is equal to IR. Then I is equal to V by R. Na? Substitute here. V by R. Then it will be V square by R. P is equal to V square by R. P is equal to V square by R. Or if you required in terms of current, P is equal to VI. Then substitute V value. V is equal to IR. Na? IR into I. Then I square R. So you get two formulas. In terms of current, you have I square R. In terms of potential, you have V square by R. Okay. So see here, directly proportional to the square of current for a given resistance. See, heat produces H is equal to H by T na. H by T is equal to VI na. VI, how can we write? I square R. Okay, then T will go this side. I square R T. Okay, then H is equal to I square R T. This is the Joule's law. Okay, H proportional to I square, H proportional to resistance, H proportional to time. H proportional to time. Current is square of the current. Okay, increases, heat increases. Resistance increases. See, if I'm taking one resistance here, if I'm taking one more resistance here, where the heat will be more? First one or second? Second one automatically. Because resistance is more. Okay, collision will be more, then heat will be more. Okay, more amount of heat it produces where? If more resistance is there, high resistance is there, high amount of heat it produces. Okay, and time taken, time increases, amount of heat also increases. Okay, H is equal to I square RT. Okay, H is equal to I square RT. What we called? What we called? Joule's law of heating. Okay, remember the formula. H is equal to I square RT. Okay, can we go for next one? Yeah. See, an electrical iron is there. How much resistance is there? 20 ohms. Okay, write the solution. Given information. What is the given information? What is the given information? An electrical iron is given. Okay, resistance of electrical iron. Resistance of iron is equal to 20 ohms. Okay, fine. Takes a current of 5 amperes. How much current is passing through that iron box? How much current? I is equal to 5 amperes of current. Okay, fine. Calculate the heat. Calculate the heat developed in 30 seconds. Time is also given. 30 seconds of time. What do we want to find out? H value we are going to find. Based on this, you have any formula? You have any formula? You have any formula? Anybody from comment section? Any formula? You know that? Based on I, based on R, based on T. Have any formula? Do you know? Anybody? Huh? See, just now we discussed now. Joule's law of heating. What is the Joule's law? H is equal to I square or T na. I square RT. I value 5 square, R value 20, T value 30. So 25, R value 20, 30. 225 is a 50. Okay, 5 into 30 in 3 into 100. Okay. Next 25. 2 into 25. 2 into 25, 50. Okay, zeros, one more zero. So 15,000. 15,000 is the amount of heat generated. Okay, amount of heat 15,000 joules, some amount of heat is generated. Okay, 50 na? 1 zero added here. 225 is a 50. 1 zero added here. Already from this 0 and this 0. Total 3 zeros. 5 3 is a 15. 15,000 of joules is produces in a 30 seconds of given time. Okay, I am using an electrical iron working how much time? 30 seconds. In this 30 seconds of time, the 15,000 of joules of heat is produces. Okay, yeah. Next, practical applications of heating effects of electrical current. What are the practical applications are there? Where we use practically? If you take iron box, it produces amount of heater produces amount of heat. Okay, many electronic devices produces the amount of heat which we are going to use for heating purpose especially. Okay, boiling egg, heating only. Induction coil, heating only. Okay, cooker, heating only. So many electronic appliances are there. Okay, electric heating is also used to produce light. Electrical heating we are using for producing a light also, because if I am taking a filament, so the filament gets heated, then only it produces a light. Then only it produces light. Okay, if filament gets heated, then only it produces a light. So it has high melting point. Okay, high melting point, tungsten. See how the melting point will be 3380 degrees Celsius. This much is there. Okay, melting point is very high. Melting point is that very high. How much? How much melting point of the tungsten? 3380 degrees Celsius is the melting point of the tungsten used for filament. Used for filament. See, 3300 degrees Celsius. Anybody get doubt why we are using this much temperature? If the temperature rises, it produces more amount of heat. If more amount of heat is there, then it gives light. Okay. If any material produces heat, means it will be releases more amount of heat. Okay. Next, the bulbs usually filled with chemical inactive nitrogen and argon gases along the life of filament. Okay, which are the gases we are using in argon? Nitrogen and argon gases are we are using in a bulb. Okay. Next, yeah, another common example Joule's law eating is the fuse. Remember the word fuse. Okay, nowadays we are using MCB, miniature circuit breaker. Switch on, up, on. Okay, shock laga. Okay, see, fuse. Okay, the symbol of fuse is like this. The symbol of fuse is like this. This is the symbol of fuse. How we connected? How we connected fuse? Fuse always connected in a series. Remember, in MCQ they have a chance to ask you how fuse is connected. Always series. Okay, yeah. So why we connected? Protecting the circuits. How we connect? How we connected? It is protecting the circuits. Are we connected in series? And what is the material it made up of? Metal or an alloy? Okay, an appropriate melting point. What is the material we using? Can we use plastic, wood, or any other material? No, we will use metals. We will use mostly, or an alloy we will use. Okay. For example, metals, aluminum, copper, iron, lead, etc. Next, if current larger than specified value flows through the circuit, the temperature of the fuse wire increases, then it melt the fuse and breaks the circuit. For example, switch on off, switch on off, switch on off. Have you seen these things? Okay, switch on off. Okay. For example, I'm taking a switch here, on off, on off, on off. What happens? If continuously on off means what happened? If continuously sit and stand, sit, stand, sit, stand. If continuously doing means what happened? It affects on your muscle, right? So similarly, if continuously on off means the potential difference will be high. So it cannot take immediately. So that's why what happened? It breaks the circuit. Okay, this is the reason if continuously current is come and go means in a home, they said that all the electronic circuits will be stopped immediately. Why? Because of it creates high potential difference. Because of this high potential difference, the electrical components doesn't work. It fails. Okay, maybe circuit problem or any other issues electronic devices will come. Okay, so if potential difference will comes means it breaks the circuit and the fuse protect that electronic device, because fuse is what? From through the fuse only it passes electricity. When the fuse breaks, what happened? It doesn't pass electricity through other components, right? So the remaining all electrical equipments are safe because fuse taken high melting point. Okay, it breaks the circuit. If circuit is break, how the electricity passes through it? It doesn't passes, na? Okay, yeah. Next, the rate of doing work is called power. Rate of doing work, P is equal to work done by time. That we already know it. Okay, and P is equal to VA. Also, we got the same formula. Okay, and how we connected that? SI unit of electric power is what? Remember the word. Watt. Okay, watt. So what is that? Watt? Electric power. If your teacher is asking question, what is the unit of electric power? What is the question? What is the unit of electric power? What? What? Answer is there. What? Okay. What? What is the unit of electric power? What is the unit of electric power? Watt. What is the unit of electric power? Watt. Okay. Yeah. See, the power consumption by devices that carry 1 ampere of current when operated to potential difference of 1 volt. P is equal to VI na. P is equal to VI na. When you will get 1 watt of power, 1 watt of power, LHS is 1, that means potential is 1. Okay, that means potential is 1. That means potential is 1. Potential is 1. Current also 1. Then you will get 1 watt of, you will get 1 watt of power. Okay, when you will get 1 watt of power, potential is 1, current is 1. Then you will get 1 watt of power in a circuit. Okay, next, the commonly unit of electric energy, common unit of electrical energy is kilowatt per hour. See, which is that? Kilowatt per hour. Okay, kilowatt hour is the unit of energy. It's a common unit. Kilowatt hour. Okay, so kilo means how much value? Kilo means how much value? 10 to the power of 3. What is what? It's a unit. Okay, it's a unit. Hour means 3600 seconds. That means 3.6 into 10 to the power of 3. 2. 3.6, 10 to the power of 6 will come. Or 36 into 10 to the power of 5. Okay, so 1 kWh value is this much. Okay, 3.6 into 10 to the power of 6 joules. Okay, 3.6 into 10 to the power of 6 joules. This is the way calculating. 3.6 into 10 to the power of 6 joules, or 36 into 10 to the power of 5 joules. Anything you take. Okay, what is the kWh? It's a common unit of electrical power energy. Okay na? kWh, kilowatt hour. Kilowatt hour. Kilo 10 power 3. Hour. How many seconds are there? 3600. 3600 seconds are there. Okay. Next. Yeah. So out of two bulbs, one rated 100 volt, 220 volts, and other is 60 volt, 220 volt. Which one has higher resistance? So which one has higher resistance? Here two bulbs are there. Two bulbs are there. First take the given information. Two bulbs are there. What are they? First is that 100 watt bulb. It is connected to 220 volt. And second one is that 60 watt bulb. That is also connected to 220 volts. So the potential of 60 volt, okay, and the potential of 220 volt is same only. Okay, see, first I am taking 220 volts, 220 volts, 220 volts only. Okay, connected to bulb, the bulb glow. So how much? 60 watts. Okay, and another one, another one you take, another one you take. Here also 220 volts only, connected to the bulb. How much? How much? How many watts? 100 watts. So which is having high resistance? What are you going to find out? In this, apart from these two, which one is having high resistance? So what is the given information? Power of the two bulbs are given, P1, P2. Okay, and voltage is given. Voltage is given na 220 volts. What are you going to find out? In these two, which is having high resistance? So what is the relation between power, voltage and resistance? Power, voltage, resistance. So what is there any formula based on power, voltage, resistance? P is equal to VI na. This is the formula, right? This is the formula. We required in terms of voltage, power and resistance. So here there is no resistance. Substitute the value of resistance from the Ohm's law. V by R. Then V square by R. Power P is equal to V square by R. Power P is equal to V square by R. So in a both the circuit, how the voltage will be? How the voltage will be? Same only. So take V square is constant. Take V square is constant. Then P inversely proportional to 1 by R. Okay, if resistance increases, power decreases. Power increases, resistance decreases. It means what we required, power we know, we don't know resistance, right? Then R inversely proportional to 1 by P. R inversely proportional to 1 by P. If power is more, resistance is less. If power is less, resistance is more. Okay. So compare now two bulbs which is having more power, 100 watts. Okay. Power more, power is more, resistance is less. Power is less, resistance is more. So which one is having more resistance? Anybody from comment section? Anybody from comment section? No need to calculate because the potential is same. No need to calculate. So find out the relation between power and resistance. Anybody from comment section? Yes. 60 watt bulb. Because 60 watts, power is less, power less, resistance will be high. Both are inverse. So 60 watt bulb has more resistance. Okay. 60 watt bulb more resistance than 100 watt. Okay. Next, in a house. Okay. Next question. See, there is a house. In the house, 560 bulbs are there. Okay. I'm taking one bulb, two bulb, three bulb, four bulb, five bulbs. Okay. Or else, or else, or else, five bulbs are there. Okay. Five bulbs. So I'm taking one bulb. What is that? 60 watt. Okay. Power how much? 60 watt. Like this, five bulbs are there. Okay. Like this, five bulbs are there. Five bulbs are there. 5 or 60 only. Okay. 5 or 60 bulbs only. Next, are used for 5 hours. How much? How many hours they use it? For 5 hours. Okay. I'm taking a bulb. From past 2 hours, I'm using the bulb only. Similarly, 5 bulbs I'm using 2 hours. So in their house, 5 bulbs are there. How much time they are utilizing these 5 bulbs? 5 hours daily. Okay, and each day 5 hours. Today is 5 hours, tomorrow 5 hours, day after tomorrow 5 hours. So each day 5 hours daily. Okay, next, and two heaters also. Two heaters also. What is the power of them? Power of them P2 is equal to power of the heater is equal to 1000 watts. 1000 watts are used for time. Here time is that 5 hours. Here time is for T2 is equal to 2 hours daily. So bulbs also using daily, heater also using daily only. Calculate total energy consumed in a month of 30 days. Okay. So daily they are using. Daily. Okay. In a month 30 days are there. For these 30 days, how much energy, total energy for 30 days. Okay. And cost of the rate is per unit. Per unit, how much? 4 rupees. Per unit, 4 rupees. Okay. Per unit, 4 rupees. See here, kWh, kilowatt per hour, is called as a unit. Whenever kWh is there, you can use 1 unit. Okay. That means 3.6 10 to the power of 6 joules na. Okay. kWh value we use for 1 unit. kWh is there 1 unit. Okay. Kilowatt power, commonly known as unit. kWh called as that unit. Now see here, how much? 5 hours, 60 watts. Okay, calculate the total energy. Calculate the total energy. Total energy is equal to 5 hours daily. Daily 5 hours. How much power? 60 watts. How many days? 30 days. Okay. Just a minute. Okay, so 5 hours, 5 hours, 60 watts, right? How much? 5 hours, 5 into hour, convert into 60, 3600 into 60, 3600 into 60. Okay, converted hour na, per hour 3600 seconds. Okay, each day. How can we calculate? Power is equal to work done by time only na. Power is equal to work done by time. 60 watts. It is given a 60 watt time. What you going to find out? Energy of the total 5 bulbs. Okay, 5 hours, 5 hours, 5 hours, 5 bulbs, each bulb having 60 watts. Calculate 25 into 60, 6 into 10. 625 sir. Okay, I am taking kWh only because finally I will convert into kWh value converting into unit. Okay, so instead of taking 3600 1 kWh value, I am converting into unit only. So 5 hours, 5 hours, 5 bulb, each bulb is that 60 watt. Then 6 into 25, 6 into 25, 150, right? 150. Then 10, 1500. Means 1500 by 1000. 1500 by 1000. That means 1.5 units. 1.5 units only by bulbs. Okay, 5 bulbs continuously. Okay, 5 bulbs continuously used means how much? How many units? 1.5 units. And coming to the heater also, 2 hours. Okay, 2 hours daily. How many heaters? 2 heaters. Each one 1000 watts. It means 4000 by 1000. Okay, because I'm converting into units. Converting into units. So 4 units. This is E2. E2 is 4 unit. E1 is 1.5 unit. E2 by the heater I will get 4 units of current because you know, right, if you are using a heater, because of heater get more electricity, more amount of heat is generated, then more work, more energy is required. Okay, so that's why whenever we are using a heater, then the current bill will be high. Observe it, whenever you are using a heater, at that particular month the bill will be high. So because it takes more amount of heat is required. So for heaters, two heaters only 4 unit of current, but 5 bulbs 1.5 units only. Then total means E net is equal to, total energy is equal to E1 plus E2. E1 how much? 1.5. E2 4. Totally 5.5 units of current. Okay. This is for one day. Only for one day. Total energy in a day 5.5 units. Then 30 days 5.5 into 30. So 0 point cancel. 55 into 30. 165. Okay. 165 units. 165 units in a month of 30 days. In a month of 30 days, how many units amount of energy? 165 units. Okay, and each unit cost is 4 rupees. Now the problem is not done. Okay, for each unit 4 rupees. How many units are there? 165 units are there. Anybody from comment section calculate and tell me 165 into 4. 165 into 4. Calculate. For each unit 4 rupees. Okay, so then 165 units means 165 into 4. 4 16 640. 640 into 4 5 20. So 660 rupees. 660 rupees is the bill only by this. 660 rupees is the only bill by using 2 heaters and 5 bulbs. Okay. Yeah. Clear na? Next, summary. Okay. So let's recap very quickly what we discussed in today's section. The resistance of system of resistors. Okay. So system of resistors is nothing but combination of resistor. How the resistors will be. Okay. When series end to end connection. End to end connection is there series. When it will be parallel, step by step. Okay. Step by step. That means one resistor by another resistor by another resistor. Okay. Step by step. Parallel. Heating effect of electrical current. If you use any electronic devices, it produces some amount of heat. That is called heating effect of electric current. In the heating effect of electrical current, Joule's law is there. What is that Joule's law? H is equal to I square RT. H is equal to I square RT. H proportional to square of the current, proportional to resistance, proportional to the time period. Okay. Next, electrical power. How can we calculate power? Work done by time. From this work done by time, we will get P is equal to the relation with potential and current. P is equal to VI. Okay. In terms of potential, P is equal to V square by R. Okay. And in terms of current, P is equal to I square R. Okay. When the potential is constant, if you want to calculate the power and resistance, if the potential is constant, power is more, resistance is less. Power is less, resistance is more. Simple. Okay. See the relation among them. Okay. Na? Yeah. That's all for today. I hope you all enjoy the class. Okay. Let's meet in another section. The same energy and same joy. Okay. Have a nice day. See you soon. Thank you all.